we are going to look at another thing is the normal distribution. Normal distribution. What is the meaning of normal distribution and what are the properties of normal distribution in the estimation model? So normal distribution simply is the probability function that describes how a variable of value of a variable are distributed over time. Now, I've said it before. There are so many variables, mostly time series variables are not normally distributed. The reason is because sometimes there are some seasonal variation that could make a variable or observation not actual what it's supposed to be. You know, that is a kind of a little contraction, a little interaction or a little interference in that data. So all these things makes time series variable not normally distributed over time. So in observing any phenomenon, it is always advisable that you should allow the phenomenon to only change, you know, because of time. It only change because of time. So allowing time to bring the changes. But if other thing outside the time that the observation is taking, you know, influence the value of the observation, it means there's some abnormality, and there we need to normalize it. So every variable, the value needed to be normally distributed. And conventionally in statistics, when you say normal distribution, you are talking of zero mean and unit variance. A normal distribution, simply in the simplest definition in statistics, is a distribution that has zero mean and equal variance. Zero mean and equal variance, where the mu is equal to 0 and the sigma square is equal to 1. Every distribution that observes this is normally distributed. So there are some reasons for this normally distributed listing in order to have an informed decision and a good decision. So a normal distribution is best suited for data that at the minimum meet the following condition. One is that there is a strong tendency for the data to take on a central value. That is the mean. So positive and negative deviation from the central value are equally likely. So we are talking of, again, the variance. So the frequency of the deviation falls off rapidly as we move further away from, that is the decaying nature of the distance. That even when the value move out of the mean, it won't last long before it comes back. So the period of decay, we call it decomposition, must be rapid, must be fast. So it means that whenever the data moves out of the mean, it must come back quickly to the mean. So these are some of the conditions. So the last two conditions shows up when we compute the parameter of the normal distribution. So the symmetrics of deviation leads to 0. I've said skew and low probability of light deviation. So all these are features of this. So we look at how we graph the normal distribution. So the graph of a normal distribution is characterized by two parameters, the mean and the average. The mean and the average, which is the maximum of the graph and about which the graph is always symmetric. And the standard deviation, which determines the amount of dispersion, as we say, away from the mean. So we normally check the distance, the dispersion, the deviation of the variable out of the mean and the mean. So a normal distribution, as I've told you before, our key is the variance. The variance, try to look at the deviation, the standard deviation. Remember that the square of standard deviation is variance. So it checks how much deviation from the mean and what is the mean. Like I said, the mean is always 0 and the variance is always 1 for you to get accurate normality. So you see a normal distribution on the board that has a U-shape curved all over. You see that the color we tag yellow here shows the normal curve of a mean distribution, normal distribution of intelligent quotient. So this is a typical, in this case, it did not skew towards one side. So a skewed one-sided normal distribution, they try to say the type of tail. It means that the variance is not unity. It doesn't have equal variance. But the normal distribution should have equal variance. The two sides must be equal. So it must be in U shape, not skewing to the left or skewing to the right. So this is a typical normal distribution. So what are the properties of normal distribution? So normal probability distribution is a bell shape. As we said, that is the U shape you saw there. It's a bell shape. So one is that it is a bell shape, and the area within one standard deviation of the mean is approximately 0.68. That is on some distribution. So when you talk of some distribution, within two standard deviation, the area is 0.95. That is for another distribution, and for the third standard deviation is 0.00. This is supposed to be 0.0997. These are, normally when you want to check normal distribution is alpha divided by 2 when you are talking of two-tailed test. So these are the resultants. So a normal distribution is symmetrically about the mean. Like we said, it is always having mean 0. That is, the means are symmetrical. So the location, the spread of a normal distribution depends on the value of the population mean, as we said, and the standard deviation. Remember that the variance of a normal distribution that I said must be unity depends on the standard deviation. So in a normal distribution, the frequency of observation is highest at the mean, which is almost equal to the mode or median. We always see that. So the range of normal distribution is infinite because the tail never touch the horizontal axis. And whenever you see a normal distribution, it can never come and the tail is touching. It's always curved, leaving some gap there. So that is why we discussed about the highest mean of the normal distribution. So it doesn't touch the horizontal axis. It's always curved down a bell shape close to the horizontal axis and leave some gap within the horizontal axis. So when a normal distribution is normal in shape, we can determine the exact relative standing of that observation. That is quite alright. So a standard normal distribution is one in which the mean, I've said, is equal 0 and the variance was equal 1. So far so good. We've also discussed about normal distribution, the properties of normal distribution, the features of normal distribution, and how can a distribution be typed as a normal distribution. What are the characteristics and what are the features? So we've discussed how a normal distribution could skew to one side, or the ketosis of a normal distribution is always a 3. So we'll discuss that.